A company wants to know if attending a course on how to be a successful salesperson can increase the average sales of their employees. So they sent 6 salespeople to attend the course, and we have the 1 week sales before and after attending the course. We want to know if the course increases sales at a 5% level and what conditions or assumptions are necessary for our test to be valid. So when we're working with this data set, these are paired because these are the same people before and after, so the same person. So our sample size is of 6, so I'll call that N sub D. What we want to work with is difference data, which we'll call D, so our difference data D, and so we need to subtract the values. It's up to you when you start how you subtract. I'm going to do after minus before here. So if I take for the first person the 18 minus 12, I get a difference of 6. 24 minus 18, difference of 6. 24 minus 25, difference of -1, and so on. So this is the data we now want to work with. We would take that and plug it in our calculator, get a mean, which I'll call X bar sub D, is 4.167. Standard deviation of those 6 values is 2.639. And because this is a small sample, we are, in order to use t-based inference, assuming that the difference data comes from a normal population, which we could check by graphing and making sure that that seemed like a valid assumption. So our null alternative, we're testing for the difference in the population means in the sense that we would subtract and then look at that mean. So we test for mu sub D equals 0, which would say that before and after, if we did that for the entire population of salespeople and subtracted, that average is 0. So I mean the course had no impact. Now we need to look for picking our sign here at how we subtracted, and how we subtract is important in terms of what direction we want here. We want to know if the course increases sales. If the course increased sales and I did after minus before, we want to think about if we should have positives or negatives for our differences. If we have an increase in sale, then after should be bigger than before, and so this should be a positive quantity. So we want to test if mu sub D is greater than 0. Had you chose to subtract the other way and do before minus after, then you would do a less than 0. So you just want to make sure you're consistent and making sure your alternative matches how you subtracted. Okay, our test stat will be the sample mean over standard deviation divided by square root of n, which is equal to 3.868. Degrees of freedom is n minus 1, so we get 5. And so we are doing a right-tailed test with a 3.868. So t distribution, degrees of freedom of 5, and then right tail, and 3.868. And so we get a p-value of 0.0059. So that being compared to a 0.05, 0.0059 is less than 0.05. This would lead us to reject our null and say that we have significant evidence that population mean sales are higher after attending the course.